All right, units 5 and 6 both dealt with polynomials. And essentially we had a whole mash of skills in here. We were expanding polynomials and factoring them and solving polynomial equations and graphing functions and understanding the function's degree and when the first differences or second differences were constant, all those things. Even and odd was another topic. And all of these things, it was a very, very long stretch where we were doing nothing but polynomials. I've picked a few sort of typical examples of stuff that you'll be asked to do on the exam for polynomial functions and polynomial equations, and of course the two units are very, 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 very tied, so I'm not going to worry about which question is from which unit. It's just all skills involving polynomials. And sometimes you'll be using the TI-83, sometimes you won't. Sometimes it'll be inappropriate to use the TI-83, and sometimes it'll be totally appropriate, and this will be something that you'll have to practice when you're reviewing. So let's get to the first example. Some typical, this will be questions that are similar to the multiple choice questions here, folks. You've got a polynomial function there, and we're asked to state some stuff about it. Let me just get the thinner pen here, and then I can write good. All right. So as x approaches infinity, y approaches. Now this is either going to be negative infinity or positive infinity, but if we think about this, it's cubic, right? But the leading coefficient's negative, so it kind of behaves like a line. It starts in one spot and goes to the other, and since it's negative, it starts high and ends low. We don't know where, we'd have to factor it, but it starts high, ends low. Starts high, ends low, odd degree. So as x approaches infinity, that's ending, right? We're talking about end. Ends low. So how do we say low? Negative infinity. The y-intercept, well, the y-intercept is just f at 0, right? F at 0. These all wipe out. We're left with 8. Easy peasy. The range, well, since it starts high and keeps going forever and ends low and keeps going forever, what's the range? Well, it's y is a member of the reals. All real numbers are in the range. Remember, range is outputs, domain is inputs. For this one, x goes to negative infinity, y goes where? Well, what do we got? There's the degree is 2, 3, 4, so it's degree 4. So it means it's an m or a w, right? M or w. And what's it going to look like? Well, a nice little sketch will help us get all of this stuff. It has a 0 at -3, at 4 over here, and at -8. Remember, it's always the opposite. Oops, -8. It would be a w if the leading coefficient was negative or positive, but it's negative, so it's an m. It starts low and ends low. That's supposed to be an 8 there. Slash, bounce, slash. That would be the sketch, and I think we got a graph like this coming up. As x goes to negative infinity, so this is the start, right? X is way off on the left here. What happens to y? Y goes to negative infinity. It starts low, right? This is starts low. The y-intercept, well, it's right there, but again, that's just g at 0. You can put that into a calculator. Hopefully you figure that out. And I got, even though it seems strange, 576. And remember, when we're doing sketches, we just put in 576 there, right? We didn't care how far up this was. This would give us some perspective on the scale. The x-intercepts, well, those are the zeros, right? We had -8, and we had -3, and we had +4. All the opposites of the brackets. G at 1, again, just jam that into a calculator. I got 864. And so notice my diagram's a little bit messed up. It looks like it's going downhill there, but it actually goes up to 864. All right, onward. Determine the equation of the polynomial function of degree 4 with x-intercepts, blah, 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 blah. So 4 intercepts, all slash roots. All right, we got 1 and minus 2, 5 and 6. Degree 4, so these all have to, can't be any bounces here, have to be slashes, and passes through 312. 312. So that means if it has to go through 312, it's probably going this way, right? We don't know that that's the high point there. That's kind of a bad sketch. But what do we have to find? Well, we want to find the equation. We know that each of those roots leads to a bracket, right? Each of the roots lead to a bracket. But we don't know the stretch factor, right? We don't know the stretch factor that's going to give us running into 312. So how do we do that? We're going to use that point. When x is 3, y is 12. When x is 3, y is 12. And that's supposed to be a bracket there. And then you figure that all out, and that, according to my calculations, is 60. Divide both sides by 60, and we get a is 1/5, or 0.2. So therefore, the equation is 0.2, and then each of those brackets. Pretty good thinking question, because we never really did any like this in the year, but really drives home whether you understand what these graphs are all about. Example 3, sketch the graphs. I'm actually going to skip that one. We just did one that's almost exactly like that, so I'm going to skip. Keep moving. It's very much like the sketch that we did for this one here, isn't it? Where we did the roots and no problem. We know it's going to be a quartic, starts low, ends low, that sort of thing. This one is harder because we don't know any of the roots, but what do? We have to factor it, right? So I'm going to take out a factor of 4x and get x squared minus 3x minus 15, and keep factoring. All right, this is a easy trinomial, numbers that multiply to get oh, is that right? Oh, hang on. What do I need here? Did I mess that up? Let me have a look at this. Yes, I did. I goofed that one up, but that's okay. We can do it. This actually, this thing here, right here, doesn't factor. But does that mean that there's only one root? X equals 0. I can see that that's a root, an X-intercept, but does it mean that this cubic, and I know it's a cubic, obviously, does it only have one root? Like, is it doing this? Starts low, ends high. Is it like that? Well, not necessarily. Remember, we could get roots from this, from the quadratic formula, right? I want to find out when this is equal to 0. So I can use negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1 and b is negative 3 and c is negative 15. And you keep doing that and show some patience on your calculator, and you'll end up, oh, this is a mess, sorry about my handwriting there, folks, but x is, and so I'm going to put dot dot dot, x is about, to find the answers, negative 2.65, and x is about 5.65. So it's not this at all. And I'll do the sketch real quick here. So we got a root at 0, a root at negative 2.65 rather, and at 5.65. They're all slash roots. Positive leading coefficient, so it starts low, and ends high. We'd have to do a calculation somewhere to find some scale on this, right? So you put in x is 1 and calculate what that would be. X is 1 would be 4 minus 12 minus 60 is negative 68. So x is 1. That's negative 68 way down there. Okay, that's supposed to be an arrow. 1, negative 68. And that's it. There's the sketch. Dandy. So that was kind of a nice miss. It didn't factor, so we had to use the quadratic formula, which came up more in Unit 6, I think, although we don't really care which is which. Here we go. Solve for x. We were just doing this. Give answers correct. How are we doing for time? Now, is this the last example? No, there's a couple examples. I'm going to pause here and make a video too.